Good morning and afternoon, everybody. As we're having folks continue to join, I'm gonna launch a quick poll if you want to jump in and answer that question. And I'll go ahead and get started on getting us going here with a few logistics. Thanks for those of you who are popping an answer into the poll. So welcome to this NABC session. This is about pollination and productivity, data-driven strategies to maximize blueberry yields, featuring BeeHero. My name's Mandy Borman, and we are very grateful to have you here in attendance with us. Before we get started, just a few logistics. Please take a minute and share your Zoom name and make sure that reflects your real name. And please be sure to use the chat box. If you have any questions, we'll take some time after the presentation to answer those. And speaking of interaction, we love seeing your faces, so feel free to turn on your camera. During the Q&A portion, you can unmute yourself if you want to ask your question in person. And then if you're not asking any questions, don't forget to press mute again. And don't forget to stay till the end so that we can share any links and resources with you. As you all know, our education sessions would not be possible without the support of our dedicated members. So I'd sincerely thank BeeHero and their team for support of this session. We're very lucky to have a number of their folks on the line today. With us is the great team, and I'll let Itai, the co-founder and CGO of BeeHero, introduce them. Take it away, Itai.
Thank you very much, Mandy. First of all, again, welcome everyone, and really thank you for joining us. Hopefully, you're going to be able to learn something today, and potentially even improve your practices moving forward with blueberry pollination. So we're going to talk today a little bit about what BeeHero has to offer in terms of pollination in general, but specifically here today, we're talking about blueberries. And we're going to actually start with Lisa DeVetter, who's a professor at the Washington University. And she's studying blueberry pollination, or been studying blueberry pollination for a while, and has quite a lot of knowledge and very, very useful information. So we're going to start with the science and then move into some of the stuff that BeeHero offers that ties very well into what we're going to hear from Lisa first. So Lisa, I guess the stage is yours.
Great. Well, thank you for that introduction, Itai. I'll wait for the slides to be projected. But as those are getting posted, I just want to acknowledge that I'm one individual of many. And so just like all good efforts and outcomes, the work and the information that I'm going to be presenting on is the culmination of collaboration from the individuals that you see listed on this slide, from the institutions that you also see listed here. And I want to thank NABC and BeeHero for allowing me to come and talk about some of the great work that this project team has done. And I've titled this Pollination Insights, Optimizing Honeybee-Mediated Pollination in Blueberry. Next slide. Great. Thank you, Mandy. So I wanted to start off with a little bit of a blueberry pollination primer just to make sure we're all on the same page. Blueberry does require insect-mediated pollination to move pollen from one flower to another and then subsequently develop those nice berries that we all love and enjoy. There are some new cultivars and selections that are less dependent on insect-mediated pollination, but we see consistently that even if they don't require insect-mediated pollination, they always benefit from insect-mediated pollination. So bees are really important when it comes to optimizing yield and quality. There's many species that can pollinate blueberry. Bumblebees are well known for how effective they are because they can buzz pollinate and release pollen from those blueberry flowers. But when we look at commercially, who is doing the bulk of pollination services in blueberry fields around the world, it is the honeybee, which you'll see in the center there. And that's because we can effectively move those colonies from field to field, and we have a large mass of insects that can then pollinate those many blueberry flowers in a field. Despite that, pollination is often variable and insufficient, and that's why we do research on it, and that's why there's companies like BeeHero that are there to help growers try to optimize their pollination with honeybees. Beekeepers also have reported over the years that the health of their honeybee colonies have declined, specifically following blueberry pollination. And this overall kind of paints this need that growers and beekeepers need evidence-based strategies to improve their blueberry pollination. And so we go back and we study, we research, and then we share information so that we can then provide some of that information for those evidence-based strategies. Next slide. And that's where this project team comes into play. So we have been funded from the United States Department of Agriculture back in 2019. We've gone through doing research during the COVID era, and we've come through with a lot of information. And this presentation is going to represent the information that we have collected over the past few years. And the goal is to investigate the biology and best practices to achieve optimal pollination, and then leverage those results to create decision aid tools that growers, beekeepers, as well as crop consultants can use to inform pollination strategies. We've worked with a lot of grower cooperators, we've worked with a lot of beekeepers and technician students and time slip over the years. So it's a very large, massive effort, and we're very thankful for all the individuals that have helped us throughout the years. Next slide, please. So this is, a project that has been going on for now 5 years, and I'm going to try in the next 20 minutes or so present on some key takeaways from this research. Specifically, I'll talk about what we've learned when it comes to pollination requirements, honeybee hive placement, and stocking density, which intersects with colony size. We'll talk a bit about what we've learned about environmental effects with a focus on heat stress, and then go over some of the resources and tools that our project team has developed. Next slide, please. So I'm going to start off and talk about pollination requirements, and I want to acknowledge Dr. Stan Schaubert on the top right corner. He did the work that I'm going to be presenting on for this part of the project in the Mallinger lab at the University of Florida. So a little bit about this. We wanted to better understand the role of cross-pollination when it comes to improving blueberry pollination outcomes. So highbush blueberry has a high degree of self-fertility, and that means pollen from the same flower, plant, or cultivar can land on the stigmatic surface of a blueberry flower, and it can germinate and lead to initial fertilization and berry development. But the whole genus of Vaccinium is partially self-sterile with an early acting inbreeding depression. Practically what this means is when we have self-pollination with pollen from the same plant, flower, or cultivar, it leads to embryo abortion, and that can lead to some of those seeds aborting. And that's important because if we don't have seed development or high seed development, we have a limited amount of hormones being released from those seeds that are really integral and important for berry expansion and sizing, as well as just fruit set. So what Dr. Schaubert did is in greenhouse studies using small potted blueberry plants is he took different southern and northern highbush blueberries represented by NHB and SHB, and he did careful and controlled cross-pollination and self-pollination studies and looked at the outcome. And overall, what he found is that cross-pollination improves pollination outcomes in most of those northern highbush and southern highbush cultivars. In the next slide that we're going to be looking at, we'll look at some of those results. Next slide, please. And here's a nice schematic that shows what we learned when it comes to cross-pollination in northern highbush blueberry. The results for southern highbush blueberry mirror this. So in this table, you'll see the cultivar in the blue column on the left, what that cultivar was crossed with, and the changes that we saw when it comes to fruit mass or size, firmness, fruit set, and ripening time. And it's a qualitative table, so it's not necessarily showing you the percent gain. Let's jump right back into this. So this table just shows what happens when we have a cultivar of northern highbush blueberry shown on the left, crossed with different genetics. So Duke Draper, Draper, Duke, and Legacy, and then the changes that we see when it comes to fruit mass, firmness, fruit set, and ripening time. And the key takeaway here is if you can see the positive signs highlighted in green, that most of the northern high bush cultivars that were considered in this study saw improvements when we had cross-pollination relative to self-pollination. Now, this was done in a greenhouse with small potted plants. The next step that we hope to explore through research is whether or not the magnitude and the effects that we see in the greenhouse study translate to field conditions with mature bushes. Next slide, please. So we're going to leave behind pollination requirements and now talk about hive placement. I want to acknowledge former graduate student and postdoctoral researcher who worked in my program, Ms. Kayla Brower and Dr. Maxime Erhartz. A little bit about a background about this project. So honeybee hives are often dispersed along the edges of blueberry fields. That's certainly common in the Pacific Northwest where I'm located, and it's represented by this picture that you see here. The idea here is that honeybee is not very attracted to blueberry blossoms, and so growers and beekeepers work closely to try to have those hives placed along the edge of the field with the idea that those honeybees are going to be less distracted to forage and pollinate other plants in the landscape that they prefer more than blueberry flowers. But there's no data justifying this practice. And this practice might also increase those honeybees to pesticide exposure, such as fungicides that are routinely applied during the bloom period to protect against different types of fungal pathogens. It's also a lot more work for beekeepers to place those colonies on the edge of the field, as opposed to aggregating and clumping them together on the edge of a field. So we asked the question, well, what about clumping hives? Does that have an impact on pollination? And that's subsequently the question that we investigated in this project. Next slide, please. So this was a very large study. In Washington State, we utilized the cultivar Duke, and we had 12 fields that we considered in 2021 and 2022. In Oregon, we also used the cultivar Duke with 6 and 8 fields studied in 2021 and 2022 respectively. And then our collaborators in Michigan utilized Duke Blue Crop with 8 fields in 2021 and 2022. And we call this a pair design where our placement treatment was not correlated with the stalking density. That's really meant to look at the effects of placement and not stalking density. Next slide, please. And these two pictures provide a visual representation of what our two treatments looked like. We had our clump treatment on the left, where we had our pallets of hives aggregated together and placed a minimum of 30 feet away from the field edge. And that was compared to our dispersed treatment, where the hives were placed along the edge of the field. Next slide, please. What we did to look at honeybee activity is we had 4 transects that went down the length of a row that were 330 feet. And throughout the bloom period, we measured or counted the number of honeybees and other insect pollinators pollinating those flowers. We also looked at pollination outcomes from 20 bushes per field site. Those are represented by the red stars. So there were 5 bushes per row or transect. And we looked at flower count and then fruit set to look at how many of those flowers converted into blueberries. We looked at fruit weight, and then we looked at seed set, which is a good proxy for pollination. And again, we had our 2 treatments. We had sites that had either the dispersed treatment shown with the blue boxes on the bottom of that picture on the left, or we had sites that had the clump treatment with those pallets of hives aggregated together and away from the edge of the field. Next slide. What did we learn? Well, the results were pretty surprising. What we saw consistently throughout the study was that clumping increased honeybee visitation to blueberry flowers. And that's what the figure on the left shows is we've got honeybees per transect per hour and our 2 different treatments. Overall, we saw greater honeybees visiting flowers in the clump treatment relative to the dispersed treatment. And then the table on the top right shows the statistical significance. So I'm a researcher, and we want to make sure that when we're talking about the results, we can tie that to a statistical effect. So what you see on the table, we have different variables that we looked at. So region, placement, density, and then interactions. And then the p-value just is an indication of statistical significance. If it's below 0.05, that indicates that we saw a statistically significant relationship. So what we saw is that our placement treatment did lead to a statistically significant effect, and the other variables that we included and looked at were not statistically significant. In fact, what we saw is that clumping the hives led to a 2.6 and a 1.3-fold increase in honeybee visitation to those blueberry flowers in the Midwest, represented by Michigan, and the Pacific Northwest, represented by Washington and Oregon, respectively. And there was no effect, again, on stocking density. We also looked at the relationship between our treatment on fruit set, berry weight, and seed set, but we saw no statistically significant effect. And what we conclude here is that even though we saw increased honeybee visitation, those fields were already being adequately pollinated in the study, where the addition of additional honeybees didn't lead to any gains in these variables. Next slide. We also did some work where we looked at pesticide exposure based on our placement treatment. This was done in collaboration with the McArt Lab at Cornell University. For 10 hives that we had in our different field sites, we placed silicone bands, which is circled in red, and those were placed during the bloom period and passively sampled for pesticides in the environment. We had 10 bands per field, 5 were oriented towards the field, and then 5 were oriented away from the field edge, and the pesticides were analyzed using a combination of gas and liquid chromatography. We did this both in 2021 and 2022, but we only have 2021 data analyzed at this point. Next slide. So what we saw is we saw that there was a lot of variation. We detected 49 pesticides in total. When we look at the aggregate data shown on the right, where we have mean pesticide residues for our different treatments and our different states, we saw placement had no effect, whereas orientation, so facing towards or away from the field, did have an effect in Washington and Oregon. And what we saw is that, as you would expect, when the hives were facing towards the field, they had more pesticides in Washington and Oregon relative to facing away. And that's expected because we would expect drift to be, striking or interacting with those hives when they're facing the field. But again, there was a lot of variation. In Washington, we had the opportunity to do a case study approach because we had one grower that was managing 5 different field sites, and the management was consistent. On the next slide, we're going to be looking at those data. So next slide, please. And for those different field sites, 3 of them were clumped and 2 were dispersed. So again, we did this case study analysis in Washington because we knew management was consistent and management likely had an impact on our overall results that we analyzed across the different states. And what we saw is that residues were lower in the clump treatment, and that's shown on the figure on the left. We have our mean pesticide residues. The different colors represent the different pesticides. And then the 2 bars on the left represent our clump treatment, either facing away or towards the field. And then the 2 bars on the right in that figure represent the dispersed treatment. So we did see greater pesticide residues in the dispersed treatment, as we would expect because of their proximity to the field and drift. Our finding for the placement study overall was that clumping promotes beekeeper efficiencies. We learned that time and time again when we were doing some economic evaluations with our economics team on this project. So it promoted beekeeper efficiencies when it comes to deploying and removing those fields and managing during the pollination period. It didn't compromise crop pollination. In fact, we saw an increase in honeybee activity when we had clumped treatments, and then it might also reduce those colonies to pesticide exposure. Next slide, please. Now I want to talk about some of the work that former master's student at Michigan State University, Laura Goldstein, did on the topic of hive stocking density and colony size. So a little bit of background on this project. Many researchers have looked at the effect of changing hive densities and their impacts on crop pollination in blueberry, and that has led to various recommendations. But with blueberry production modernizing, with new cultivars, with higher bloom density and tighter plant spacing, there's simply more flowers per unit area to pollinate. So we thought it might be good to revisit honeybee hive stocking density for modern blueberry production systems and see if there's a need to increase those stocking densities. And we also wanted to look closely at the role of colony size, or the number of individual worker bees within a single colony. And that's something that is seldom considered in the literature, but may impact pollination success. Next slide, please. So just to further emphasize the role of colony size, many growers work with their beekeepers and have a contract for a set stocking density, such as 4 hives to the acre. But in that contract, it doesn't necessarily stipulate whether those colonies are going to have 15,000 workers, 30,000 workers, or 60,000 workers, or some number in between. And that matters because the higher colony size, the more foragers that can be allocated to pollination services, which is important for a blueberry grower. Next slide, please. So Lauren looked at this relationship. Specifically, she looked at stocking density or hives per unit area. She looked at colony strength. She combined those two variables in a metric called stocking strength, and that's return forager counts, which is a non-invasive proxy for colony strength times stocking density, and then looked at how that impacted bee visitation to blueberry flowers and pollination and yield. And this figure here on the left is meant to show simply how these different variables impact bee visitation and pollination and yield. So any line that is black and not dotted with an X means that there's a statistically significant relationship. And any dot line that is black and dashed with a red X through it means that there's no statistically significant relationship. And it's important to mention too, for this study, we utilize the same sites that we used for the previous study on colony placement. So this was a large data set that we were using. What we saw was that increasing honeybee visitation improves pollination and yield to a point. It can certainly become saturated where additional bee visitation doesn't improve berry size or yield outcomes. And then what we also learned, and that's a key takeaway for us here today, is that honeybee visitation is best predicted or related to stocking strength. And this really underscores the importance of not just stocking enough bees, but ensuring that you have good strength or populous colonies. Next slide, please. Moving through here, I want to talk about what we learned when it comes to weather effects on pollen germination. This was work done by former PhD student, Dr. Jenna Walters, who was at Michigan State University. She identified critical thresholds for heat on pollen germination. And that's really important because we need viable functioning blueberry pollen to fertilize and lead to initial seed development and berry enlargement. She did in vitro studies where she took blueberry pollen of different cultivars and she exposed them to a gradient of different temperatures and looked at pollen germination and tube growth length. And she observed that pollen performance declines and is non-recoverable as temperatures increase. And this was a key takeaway from this project, is that extreme heat reduces pollen viability and functioning, risking pollination success, and a threshold of 87 degrees Fahrenheit was identified, where temperatures above 87 degrees Fahrenheit, we start to see reductions in pollen germination. And once we get to 90 and 95 degrees Fahrenheit, we start to see non-recoverable damage across the different cultivars. And that's what the figure on the right is showing. Next slide, please. We're continuing on with this work on heat and its effects on blueberry pollen and pollen performance, and specifically looking at different ways to mitigate the negative effects of heat through funding from the Northwest Center for Small Fruits Research. So we have a graduate student working on this, Micah Evault, and this is another collaborative project with Dr. Rufus Isaacs at Michigan State University and Dr. David Bryla at USDRS. And we have completed year 1 of this project, where we're looking at how evaporative cooling or overhead cooling with water, biostimulants, and ground covers impact flower temperature, pollination, and bee activity. And I'd be happy to talk more about that work. We're going to be presenting on year 1 data in winter conferences and spring conferences in 2025 and 2026. Next slide, please. Lastly, I want to talk about some of the pollination resources that we've generated as a project team. I want to acknowledge Dr. Anthony Milithopoulos at Oregon State University. He was the lead on our extension initiative for this project, and Selena Helmrich, who is a PhD student co-advised by myself and Dr. David Crowder. We have a website that you can access on the left. This website is being actively updated. In fact, today we made some updates. So if you visit it today, make sure you visit it in about a month or so, because there'll be more information and new tools available. We have resources such as the one in the middle, which gives a grower or a beekeeper or consultant a way to quickly assess non-invasively colony strength by looking at return forager counts. And then on the right, we have a document that my student Selena just completed earlier this year, and that's best practices for pollinating northern highbush blueberry. And my counterpart, Dr. Rachel Mallinger, has a similar one available on our website for southern highbush blueberry. So feel free to check those out. Next slide, please. We also created 2 decision aid tools. The first one on the left is a bloom predictor. And what this does is estimate the timing of bloom and progression. And this is really meant to be useful for growers and beekeepers to align the arrival of those honeybee colonies around 10% bloom, and then the departure of those colonies, which is really critical for the Pacific Northwest and other regions where we want to make sure those honeybee colonies are removed, and then growers can subsequently engage in pest management practices, such as aphid management practices. So that's what the figure on the left shows, and that's available through Washington State University Decision Aid Systems for free. And then Michigan State University has this also available through EnviroWeather. On the right, we have a stocking density tool that we've developed. And this is one that we've just released, and it helps a grower understand the impacts of different stocking densities on fruit set, berry weight, estimated partial yield, and then income, taking into account a grading of different stocking densities. Next slide, please. So here are some general conclusions from the cumulative work that we've done over the years on this project. I just want to leave you with these takeaways. So one is honeybees are globally important pollinators of blueberry, and they're really critical for pollinating our crop. We've seen cross-pollination is beneficial for most cultivars in greenhouse studies, and we'd like to study more about this relationship in open field studies with mature bushes. We also saw that clumping hives promotes beekeeper efficiencies and may reduce pesticide exposures without compromising crop pollination. When it comes to stocking density, the traditional stocking densities where we're looking at simply a number of hives per unit area misses the important contributions of colony size or strength, and growers should have a conversation with their beekeepers and strive to get high quality populous colonies for their pollination services. We also saw extreme heat threatens pollination, and there's continued work exploring ways to mitigate the negative effects of heat stress on pollination. And then the last 2 points, we have decision aid tools, promote evidence-based decision-making, and BeeHero is one company in that ecosystem that is there to provide evidence-based decision-making capabilities for growers. And then last but not least, this is a presentation that focuses on honeybees, but wild bees are also still important pollinators for blueberry as well as other crops, and they are part of a resilient pollination portfolio. Next slide, please. So I want to thank everyone for inviting me here today, as well as funding from the United States Department of Agriculture. My email is there if you have any questions after this webinar. But again, I want to thank you all for your attention and hand it over to Itai with BeeHero.
Thank you so much, Lisa. I've listened to this presentation before, and still I feel like I've learned a lot, and this is really, really great. A lot of important insights here. So thank you again. Okay, so hopefully everybody has still some attention span. I know in this age, our attention span is not very long. But what I'm going to talk to you about is BeeHero, what we do, what type of information and insights you can gather or understand by working with us. And maybe I'll start with my personal background. And Mandy, if we can go to the next slide, please. This is me when I was 13. If you can zoom in there, everybody on their personal laptop, you might see the resemblance. Quite a few years later. But I grew up beekeeping. My father is the largest beekeeper in Israel. It's a commercial operation, not as big as some of the outfits out here in the US, but still a commercial operation where we pollinate a lot of different crops. And I grew up in a very agricultural environment. I saw a lot of innovation coming into many different spaces, and beekeepers and pollination specifically, we were left behind in a way, and this is what got me into what we're doing today. I met my co-founders in university. They're coming from a more technological background, and this is how we kind of started playing around with bees and pollination and sensors and tech, and trying to understand what we can do with it. So we started the company in 2017 and really started working in the US in 2019. And today, BeeHero is the largest pollination provider in the world. We work mainly in the US and in Australia, but we do have some presence in other places like Europe and even Canada. So yeah, let's dive in. So let's go to the next slide. And this is a question for everybody here in attendance. And what I want to ask, and just drop a check mark in the chat. How many of you are already tracking pollination data on your farm? And it can be many different ways. It doesn't need to be with technology. Maybe you bring inspectors to the field. Maybe you guys go on your own out there and you have your own method to look at it. I'm just curious to kind of see if there's relatively a large amount of people that already do it. See one check mark so far. But okay, we'll move to the next slide. You can still drop your check marks in there. Mandy, this is going to be a bit challenging because, according to the title, because you'll have to click every time for the rest of the stuff to appear. So let's go with another click. Okay, so the traditional approach of pollinating, and this is something that you guys probably know, is ordering the amount of hives you think are needed to pollinate your crop. So you don't pay for performance, you pay for just hive counts, right? Now, Lisa kind of touched on it with the stocking strength that is dependent not only on the number of boxes that you bring in, but how strong the colonies are actually when they arrive and when they are on your field. And let me tell you this: no two colonies are born equal, right? And this is very important. When you look at a box of bees, this is just a box. This is just the physical structure that the colony resides in. But what's important is what's in there. Okay, so there's in many cases suboptimal hive placement that can lead to some coverage gaps, and there's really no visibility into pollination effectiveness until it's too late. And even if you bring an inspector, which I know in blueberries not necessarily many people do, this is just a snapshot into like the situation of the hives in that specific moment where the inspector goes through your field inspecting the hives, and the results you're going to get really depends on the weather, the day that you're doing that, how many hives you're actually inspecting. In many cases it's 10 to 15%, so you're not necessarily getting the full picture. Now let's do another click and move to the more modern need, is to verify what you're actually getting from your pollination supplier. And I think this is really important, and this is something that generally growers get for everything else that they do on their farm, except for pollination, if they do it in the traditional way. We all feel how all the inputs, everything is more expensive now. We work more for less, right? All our inputs are more expensive. What we get for our fruit is not always what we would like it to be. And we just need to become a lot more efficient, make sure that we get the return on our investment. So verification on the actual quality that you're getting is really important. The other thing is optimizing the placement, get even coverage, make sure that the bees are actually working your entire field, and then real-time monitoring during the critical pollination window that will give you the opportunity to actually know when there's a problem that needs to be addressed. Next. Yeah, we can go another click. And another one. So with our solution, the first thing that I want to touch on is that we normally use fewer hives when we talk about the physical structure. From BeeHero, you're going to get slightly less hives than what you're probably used to if you're doing the same thing every year, just getting whatever 2 hives per acre or 4 hives per acre, everybody with their own preference or stocking rate. It's not going to be that. We're going by frames. With our technology, we're actually able to understand exactly what the strength of every hive is, how many frames of working bees are in those colonies, and we work with you together to understand how many frames are needed to pollinate your crop. And then we're able to deliver that amount of frames to make sure that you're getting exactly what you're paying for. So you're not just paying for hives that are not needed. As Lisa mentioned, at some point there is a diminishing return. You're just getting more workforce that doesn't improve your yields or your pollination performances. And this is just a wasted outcome, or sorry, expense. Let's move to the next one. Guaranteed pollination power. Again, with our technology, we're able to pick and choose the right hives, the right colonies for the specific need. We have a year-round oversight of the hives that we're monitoring, and we're able to understand what their strength is before they get into your field. Next. And by the way, I'll talk about how the technology works in just a moment, but just going over some of the information here first. Real-time hive monitoring, that's another thing that you're able to get with BeeHero. You're going to have a dashboard that provides you information in real time, like flight hours, activity monitoring of the hives, how active they are at any point of the day, the distribution of hive strength and hive size, and some other stuff as well. Next. Transparent pollination. I think one thing that the pollination industry is lacking is transparency and accountability. Essentially, you're getting these white boxes, but they really like a black box for most growers. You don't really know what's in there. You don't know what it is that you're actually getting. You really have to trust your partner, and even if you have a really, really good partner as a beekeeper as a partner, every beekeeper is going to have the odd year where their hives are not doing as well. This is just how it goes, and when that happens, you might not know that this is what's going on. Next. By the way, there's also things that can be done even if the hives are already there and they're not performing well. Once you have the transparency and you know exactly what's going on, there are things that can be done, and we'll touch on this a little bit later. Maximizing pollination ROI. Again, what we're able to do is help you understand what are the actual needs of every one of your fields. And by the way, not all fields necessarily needs the exact same thing, even if they are the same variety and were planted in the same time with the same density and everything else. Maybe one of them has higher elevation or more exposed to winds and stuff like that. And because of that, the stalking strength, I'm learning fast, Lisa. I'm already using your jargon. So the stalking strength that you need is going to be potentially a bit higher. So we help you with that. And we want to make sure that you don't overspend for your pollination needs. So you're going to spend exactly what you need to spend in order to get the best outcome with your pollination. Next. And there's a lot of risk mitigation here. We have a very, very, very large pool of bees and beekeepers that we work with. At this point, we work with beekeepers in every state except for Alaska and Hawaii. We monitor over 400,000 hives, and we collect over 30 million samples of data every day. So our ability to make sure that you get very, very good hives to cover your pollination needs is something that there just doesn't exist elsewhere. We can guarantee our growers will get really, really good hives to cover their pollination needs consistently every year. So let's move to the next slide. And now I'll talk maybe a bit more generally about BeeHero and what we do. So we're a precision pollination company. We use tech to improve current practices, and we work together with our growers and with our beekeepers to find the best practices for any specific field. So essentially what we do, what you get from us is not the technology. What you get from us is pollination services, but these are pollination services that are just not available anywhere else, especially not in a sustainable, consistent way. And we use cutting edge technology to really help us with getting that, right? So we have our in-hive sensors to monitor the hives. We have a sensor in every hive, or this is what we strive for. Sometimes you'll get, 95% of the hives on your field are going to be monitored because, things happen. But generally speaking, we aim for 100% monitoring rate. And then we have a gateway outside of the hives to collect all the data and send it to our cloud to be analyzed. And again, we have the ability to monitor all of our hives all the time, understand where we have good hives or not so good hives, and only get the good hives into your field to cover your pollination needs. So if you decided that the best that the stocking strength that you need for your hive, for your field, is going to be 20 frames of bees per acre, we're going to be able to deliver exactly that, or that at the bare minimum, to make sure that you're getting the coverage. And in many cases, because we're actually using for that really strong hives, which means less physical boxes, there's actually a potential here for you to pay less for your pollination needs. So you're essentially going to get as good or better pollination services for a price that is extremely competitive in the market. And what enables that, again, is our technology and the efficiency that we can get with it. So again, we combine the cutting edge technology with legacy beekeeping, legacy farming, and a lot of things that you already know and do very well. But we add another layer just to improve all of that and make sure that you're getting what you need. I'm going to try to run a little quickly because we have only 10 minutes left and we do want to leave some time for questions. So we have two solutions. One is what I just described. It's called PASS, Precision Pollination as a Service. This is where you get your actual pollination services from BeeHero. Can you go to the next slide? Here you can see a snapshot or a screenshot from our dashboard. Let's move to the next slide. We also have something called PIP, Pollination Insight Platform, where we're using in-field sensors that are not inside the hive, they're outside on stakes or just hanging from your bushes. And we're able to monitor bee visitations to the flower, right? So bees have very different sound signature when they just, let's say, do a flyby, or they actually go into the flower to pollinate it. And we can pick up that sound signature and count and really understand, for example, the coverage that you're getting on your field. So if you go to the next slide, we can see a heat map. This was done in Washington in an apple orchard, and you can see this is every rectangle, big rectangle, or not the biggest one that is pink, just the smaller ones that goes from the bottom to the top, represents one row, and then the smaller rows within that rectangle represents a day. So it's over 5 days of these 2, 4, 6 rows. And you can see where the hives are placed compared to the trees. Every very small rectangle is a tree. The green one is the main crop trees. The brown one are the pollinizer trees. And you can see the darker it is, the more bee visitations it received over these 5 days. And the lighter it is, the less visitation. And with this specific orchard, we were able to reduce by about a third the amount of the stocking rate for this orchard, which meant also that we were able to reduce by a third the amount of dollars paid for pollination for this grower, just because we realized that when you pass the 300 feet mark from the hives, there's a drop of about 50% in visitation. And still he got a pretty uniform crop, which means he just had way more bees than what they needed. So what we did is just reduce the amount of hives, spread them more evenly across the field, and got a really good coverage. But this is just an example to some stuff that we can do together to understand what are the specific needs for your orchard, what it is that you need, so that you don't have to pay more more than what you have to for your pollination services, and still get really the best results possible. Next. So yeah, we're able to verify the hive performances, maximize your pollination ROI, and by that improve the berry quality and pricing. If you're already getting full pollination, obviously the berry quality is not going to be improved. But we've seen over the years that a lot of blueberry growers are not necessarily getting the best hives. Many beekeepers tend to split their hives after almond pollination, and then the hives are going to blueberries, even though they're coming after almonds, which means they're supposed to be very strong. They were just split, so they're not at their top or peak performances necessarily. This is not true for everyone, but it is true for some people. So with our ability to not only source the best hive, but also be completely transparent and accountable for what it is that we bring into to your fields, you are expected to get just the best pollination services that are available at a very, very competitive price. I think we're just about at the end of the presentation. Let's move to the next one. Yes. So 5 minutes for questions, I guess. Guys, one by one, please.
It'd be interesting to see how this is charged out for this service. What does it cost?
I'm not sure I understood the question.
Is this a free service?
No, not yet. Maybe in the
Okay.
future.
So what would this cost?
So the price is going to be per frame and not per hive, and it also changes between different areas. But normally it will be within what the market prices are. So if right now you're paying for a hive, I don't know, what are you paying specifically? Is it normally around, I guess it moves between 50 to 150 for some folks.
So $50 a hive.
Yeah. So normally what we do is, like I said, we charge per frame and not per hive. But if you bulk it together per acre, if you bring 2 hives per acre, and then you pay around $100 per per acre, then it'll be similar to that. I don't want to promise any specific number, just because once we start working together and you explain to us what it is that you're looking to get, how many frames exactly, and so on, how many acres, we're going to be able to provide a personalized quote. But like I said, we're normally within market prices and can be pretty competitive.
I encourage you to look at the comment section. There's questions piling up in there.
All right, I'll do that.
And I'll just add to, while Itai's reading those questions, I'm happy to stick around a little bit longer. I know we ran longer, some of that with the technology issues that we had. And then maybe I can, Itai, if you'd like, I can handle the first
Yeah.
two questions. So Mel
Yeah,
asked about organic and conventional pollination. Do you want me to tackle that one?
Sure.
Sure. So Mel, that's a great question. I haven't come across any studies in blueberry that have really compared organic and conventional pollination. I think, regardless of whether you're organic and conventional, my understanding, speaking with beekeepers, it's always best to talk about any pesticides that you plan to apply in the field when you're going to have bees around, just to make sure that they're aware what's being deployed, they're comfortable, and if there's any mitigation that they want done, you can have that conversation with your beekeeper. And then what I have seen more in the literature and studies is when it comes to landscape it's landscape that can primarily impact pollination. So do you have any other crops in the landscape that may be more attractive to honeybees? Do you have anything in the landscape that might be contributing to wild bees? And then the scale of your farm, is it large or small? If it's a smaller farm and you have more diverse habitat, you might have more contributions from wild bees as opposed to honeybees. So it's complex, but hopefully I left you with some information regarding, kind of the considerations for different farming practices and philosophies. I don't know, Itai, do you have anything else you want to add to that?
Yeah, I would add to that, from our experience, we haven't seen, major differences or any differences really between organic and conventional in terms of, how the bees perform. The one thing would be the pesticides being used during the pollination season. Obviously, and Lisa, you've touched on it a little bit. There are some effects to the bees' well-being. It also depends sometimes, if the season is very short, depends on weather in many cases, right? Then the effects of the pesticides might not kick in yet, and you're not going to see any differences. But when you have colder weather and the season is a bit longer, then you might see some issues there. There's also like just the willingness of beekeepers. This is not really scientific at all. It's more psychological. But some beekeepers just don't want to go to blueberries because of use of pesticides. And then once you have organic fields, beekeepers are going to be more inclined to service you. So just availability is going to be, I assume, a bit better. And then there's a question about commercial crops that we're handling. Generally speaking, we're doing high value crops. So we're doing almonds, apples, pears, cherries, different berries, not just blueberries. In Australia, we also do macadamias and avocados. We also do some avocados here. Canola. We do a lot of seed production, vegetable seed production. Yeah.
Great. And then I see further up on the chat, Zeev asked a question, are the decision aid tools available for the public? So some of the decision aid tools that I presented on, those are available for free to the public. The stocking density tool, that is going to be up hopefully any day. We're just working with Washington State University to make sure it meets accessibility guidelines. But that is just for one cultivar, or actually two cultivars, Blue Crop and Duke. So it's quite limited at this point. We hope to expand it in the future. And then some of the weather-based tools. Washington State University Decision Aid System has that available. And then Michigan State University growers can access EnviroWeather through Michigan State University. And I think my understanding with BeeHero, those tools are available when you work with the BeeHero services. Right.
Thank you.
Mm-hmm. Great.
There is another question: what vegetable seed production specifically?
Yeah.
For Itai.
Yeah. We've done a lot of onion seed. We've done some broccoli, radish. We're generally open to anything. I think in a lot of the vegetable seeds, they have actually pretty similar challenges to blueberries, just because they're not very attractive for bees. Like when you go to almonds, there's no question the bees are going to be on the trees because it's super attractive. There's also not a lot around at the same time for the bees to go for. So the almonds are super attractive for the bees. But then when you try to pollinate onion, and at the same time there's avocados growing nearby, or citrus are just ending their bloom, it might be really, really difficult to keep the bees on the onions field. And in those fields, we do quite a lot of the PIP work that I was talking about, where we can actually understand how many bees are visiting at any time. Because sometimes growers, they pay for the hives arrive, but then the bees don't actually work their fields, which can be a problem. And there are things that can be done, like you can, depending on when it happens, but you can switch hives or introduce additional hives. And then it'll take the bees a little bit of time before they can go out and find the nearby stuff. They will first go to what's near the hives, and so you will have a few days where the new bees that just arrived are going to be in your field. Now, this is a pretty expensive thing to do, but if your crop depends on it, you might want to do it. But before you do it, you want to know that it's actually needed. So that's why the PIP sensors are being used a lot in seed production. We're working with some of the big seed companies that I'm sure you all know.
Thanks for asking that one, Itai. I really just focus on berries, so I don't know anything about vegetable seed pollination. So you're more qualified to answer that for sure. Great.
It's actually been really interesting work because in those big companies, they have very strong scientists in-house that do quite a lot of work on understanding, the best practices for them and then for their growers. So working with them is actually it's been a very good experience for us.
Great.
Mandy?
Yeah, it doesn't seem like we have any more questions rolling in, so I think this might be a good point for us to stop.
We have a hand there.
Hi,
Daniel?
Lisa and Itai. Great presentations and really great findings, of course, over the studies. I actually applied the cross-pollination between, say, cross-compatible blueberry varieties in the South African context as well. So I'd actually like to share some of that data with you as well, and some findings.
Oh,
It was really interesting.
Fantastic.
wonderful. I think we'd all be interested in connecting up with you on that.
Of course. Thank you so much.
And thank you for joining us from South Africa.
My pleasure.
That's great. Well, if there isn't anything else or anyone else who wants to say anything before we go.
I would like to say, Mandy, sorry, go ahead.
That's okay. I think we're probably saying going to say the same thing, but I want to thank
Probably.
organizers, Mandy and Ty and Megan for organizing this. They were very well organized, and I just had to come and talk about pollination. And I really enjoyed learning more about BeeHero's platform and the services that you're providing. So thank you all.
Thank you. So yes, we wanted to say the same thing. And Mandy, again, thank you so much for hosting this. Lisa, thank you for joining us and giving your really, really amazing talk. And thank you everyone that joined. This has been a pleasure. If anybody wants more information, you're welcome to reach out to us. It's pretty easy. The website is BeeHero.io. And yeah.
Well, great. Thank you all again for joining us. And if you are interested, we will be sending out a recording of this. So I hope everyone has a great day, and thanks again. Thanks, BeeHero. Thank you, Lisa.
Thank you.
Thank you so much. Bye.